Hello friends, welcome to our Hariharan Express channel. Today another topic I will explain, that is memory reference instruction. Previous lecture I have also explained another topic, that is register reference with a certain statements. Now how it is defined or how it is generated, different register reference. Here today I will discuss regarding on memory reference instruction. Okay, memory reference instruction also depend on that is D value. D value means we have already know that is D7 value. Okay, I will explain those part. Before that, some instruction, some concept behind of memory reference I will tell you. In order to specify the micro operations needed for the execution of each instruction, it is necessary that the function that they are intended to perform be defined precisely. Okay, the function of the memory reference instructions can be defined precisely by means of a register transfer notation, like the decoded output di, for that is a, we can write a di where I defined di for I is equal to 0 to 0 1 2, that is 6. Okay, are used for that is a memory reference, and this operation decode that belongs to each instruction that can be defined, that is di whenever defined for a decoding point of view, then we will consider that is 0 to 6. Okay, and here if we go through D, like D0, D1, D2, D3, D4, D5, D6. Okay, that means here it, since it is content D0 to D6, that means D7 here is 0. Okay, D7 here is 0. In that case, because whenever I define that is a register reference or memory reference, something different ways, D7 is 0 here, but we will count D0 to D6. If D0 is 7, D7 is 1, then we can consider as a register reference or input output reference, we have already discussed. But if D7 is 0, then we will consider D0 to D6 for memory reference instruction. Okay, this is a very clear concept. If D0 is 7, other part we will consider, that is D0, D1, D2, D3, D4, D5, D6 for memory reference instruction. If D7 is equal to 1, then it has another concept, it is depend on the input, that is mode. If mode is equal to 0, then it is a register reference. If mode is equal to 1, that is a input output reference. In this way, different memory reference instruction we can define. Okay, and another concept also there, whenever I go through memory reference, the effective address of the instruction in the register address register, that is placed into the memory. Okay, and it is done through T2 time. Normally we have already discussed that is T2 time whenever decoding of that operation for memory reference, T2 time. Okay, and whenever T2 time, then what happens, it has also two ways we can define. Okay, like I is equal to 0, I is equal to 1, like this. And whenever I is 0, I is equal to 1, for the memory reference we can define direct memory access or indirect memory access. But during that time, what happens, T3 time whenever we consider, another is if T2, if we go through T2, then what happens, we just that is placed our data into the register address. Okay, register address we can place some data in T2 time, and at T3 time, that is a execution that is also started, not exactly execution started in T3 time, because previous whenever I go through some flow chart of instruction cycle up to T3, that is for execution, T3 at execution. that is a register reference or a input output reference we can execute in T3, but a memory point of view T3 not that is execute, and during T3 time or a time signal T3 that is not execute, it start the execution at T4. Okay, T2 some transfer of that, T3 also something transfer either mode direct or indirect mode, that is we have already discussed a little bit. I will show you now. Okay, now we see that is if we go through memory reference, here you see if I is equal to 0 direct and I is equal to 1 indirect, again T3 time what happens, just a transfer of data memory to address register, that transfer during T3 time. But execution actually here is done through T4 for memory reference. You see memory reference instruction at T4 time it will execute. But you see if we go through this one, you see this T3 or T3 time it is a direct address nothing, and indirect address just transfer the data from memory to address register, and T3 time also execute of register reference or the T3 time execute input output instructions, that is at T3 time it, this kind of things will be happened. But T4 time here you see execute memory reference instruction at T4 time, not T3 time. Okay, for the reason it is consider only that reference memory reference at T4 time for execution. Okay, now we see T4 time will execute the memory reference instruction. So now we see the what are the memory reference instruction. First of all we will see what are the memory reference instruction. After that we will see what kind of operation need to operate, that is we will discuss. Very simple way we can also define different memory reference instruction, just like before we know that that is a register reference instruction. We will see one after one, we will discuss. Okay. Okay, now we will see different symbols and operation. We will see. Now first part we will go through, that is a symbol. We will go through here some symbol, operation code, that is a decoder, operation decoder or decode, operation decoder. What are the decoder you use? Some symbolic description. Okay, symbolic description. We will go through. Okay, different kind of operations we can go through. Memory reference. Let us consider. We know that that is a different symbols we can use. That is D0, D1, D2, D3, D4, D5, D6. We have already discussed that is for memory reference D0 to D6. Okay, whenever I go through that these different kind of decoder, then we will see what kind of symbol we use. Okay, very simple. We can use here is a and for first D0. Okay, it is add, next is a load. Okay, and st store, branch BUN. Okay, and branch this one is equal to 0. Okay, so different symbols we can use. In this case we will see what kind of operation symbols we can use for this given symbols and decoder. First of all you see and means through accumulator. Most of the work is done through accumulator or register we see for depend on that symbols. If we go through this one, then what happens, you can write and SC and memory that is register address register. Okay, address register from memory combined with a SC through AND operation. Okay, very simple. Similarly, if we go through add what happens? Similarly, AC plus memory address register keep the data, add with a accumulator. Okay, and if we carry out, then we can also see carry out. Suppose adding up some data, if we, some data is carry, okay, carry out. And next is load. Load means very simple, AC. And D2 make it, that is load, that is accumulator, memory of data we can load. Okay. Next is store. That data store, where it is a store means AC. Load means you just load the data to AC. Store means store in memory. So reverse case, that is a memory AR. Okay, store the data from AC, accumulator to memory, because we have to store some data in a memory, very simple way. Okay, and here once that is a PC, just address register transfer to PC. Okay, and branch unconditional, actually branch unconditional it is. And another is BSA, we can define AR. Okay, means memory register receive the PC value. Okay, and PC also increase by AR plus 1. Okay, what is the AR value? It is plus 1. And last one is MAR, this value MAR it is increasing, and when the condition MAR actually you see MAR PC value is increasing, just you can also find accordingly, plus 1 is equal to 0, then PC is equal to PC plus 1. Okay, PC is equal to PC plus 1. In this way, there are different operations we can consider. Okay, so now we will see what is the concept of that, different concept, like up to that is here we see very simple way, load, add. Okay, another is store AC, very simple way, load, store, add, and. Okay, and another is here we can very simple way we can define, that is a ISZ, increment and skip if 0. It is increment if skip is 0. Okay, this is the basic concept of that is this symbol. So different ways we can also define. Okay, now we see how it is actually represented through, that is this decoder as well as a time slot. Different ways we can define. Okay, so now we will start a different operations as per this operation, and operation, add operation, like this. Okay, now we will start that different operations. Okay, now we see first we see the operation like a and, so and to AC. Okay, and to AC, because we have already discussed, that is first part is and, you see very simple way, it is and. Okay, and decode this one, AC receive the data, AC and logic circuit and with the memory of address register we will design. Okay, very simple way I will also design that part, how it is designed. Okay, so similarly first case, here you see I have already told memory reference data or memory reference instruction, whenever we need to execute, then we will go through, that is D that is a T4 time. Okay, T4 time. But it is a D0 decoder, the AND operation only consider. So the statement is defined like this: D0 for AND. So D0 and time is T4. D0 T4, it is defined like a DR. Okay, DR, the data transfer from memory register or address register from memory transfer to DR. Okay, very simple way. I will show you, because how it is a design. I will show you, then you can find out. You see here, memory register data transfer to data register. You see memory register address register from memory transfer to data register from D4. Okay, but again whole, that is logic data, that is AND logic data from SC and this data transfer to SC in the next that is time, that is D0 and T5. The statement is defined in this way. D0 T5 defined in this way. Here what happens, SC, this SC, that data transfer from, that is SC, first one SC, SC is SC, here SC, here what happens, this data already assigned DR. Okay, so that is a, we can write that is AND operation with DR. In this way you can define, because it is a memory data dot, not exactly that is a transfer. So through data register it will transfer through using logic gate, that is AND operation. Okay, in that case what happens, SC will be 0 for this operation. Okay, for this operation, after that SC will be 0. Okay, now second we will see how it will be defined. Second one is what is that is add. You see, that is add, it is add. So we can go through, that is add. Okay, add is here, add, we can go through add. Add operation. Okay, that is add to SC. Okay, add to SC. Add to SC. In this case, you see, very simple way, that addition of that number here. Initially what happens, memory data transfer to data register, again memory data transfer to data register, again SC plus data register we have to add, and some carry out bit also we define, and SC will be 0. Okay, very simple way, same thing we can also do. So that is a D, here same thing, what you write, that is a D1, it is used for D1 because it is D1, so we use D1. So D1 and T, similarly T4, because same time execute. Okay, time slot D1 T4. In this case what happens, DR, that is a memory data AR transfer to DR. Okay, and again D1 T4. Okay, that SC, DR already received that is a memory data. You see, DR already received, that is SC plus DR. You see, and E is equal to C out. Okay, SC data is SC plus data register. Okay, and E receive carry out data. Okay, E receive carry out data, and at that time SC what, 0, it will be SC 0. This is a very simple way, we do one after one. Next, third is a D3, no D2, third is a D3, the load data. Okay, very simple, load data. Load data, what load data, that is memory address data to load in a SC. Okay, that we will do, load data. So what you write, that is a LDA, or we can load to SC. Okay, what you write, same thing, it is a D2. You see, that is a D2. D2 means here we define D2 T4. Say T, same D4, and what happens, you see D2 memory data transfer to what, data register. After that transfer to SC. Okay, so DR receive memory register data. okay, memory register data, that is received. After that you will see how it is transferred to AC, okay, how to transfer to AC. In that case what happens, another T slot is required, okay, another T slot is required. Sorry, here is T5 actually, T4 is there, T5 actually here, T5, okay. Similarly, whenever I go through another, then what happens, D2, okay, D2 T5, the statement is defined here. SC, actually SC is received here, D2 here SC will receive data register data, okay. So here DSC receive DR data or data register, okay, and SC will be 0, okay, in this way. That is another is similarly here we go through that is a fourth is D3, you see D3, the store data store data is already there, load store data, okay, that is a store data, STA D3. So store data, we can write STA store AC, okay, store AC, very simply it is nothing, only store data, AC data store in a DR, okay. That is a memory, store any memory, AC data store any memory, very simply it is not so much difficult. It is we can write that is D3 because D2 over D3 T4, this statement define store memory, memory address register is there, and what data it will store, that is SC data it will store and SC will be 0 okay, SC will be 0. And another is you see address register, okay, data store in PC, very simple. So no, that is not so much difficult, this one we can use direct address register 5, okay, that is a branch on conditional, branch on conditional, okay. In that case what happens, D4 T4 such that address register data transfer to PC address register AR and SC 0. It is very simple, it is not so difficult, okay. In this way we define that. Another, okay, another is you see D5, that is a 6, okay. What you write, that is a okay. Next is similarly BSA, okay. In this case we use that is D5, okay, D5 decoder and T4, okay, T4, and it is also that is store data into memory, okay, so that is a memory AR receive data from PC, okay. And another is D5 T5 receive PC will receive data, PC receive data AR plus 1, okay, in this way, that as per this that statement. Next, that is ISZ, that is increment and skip, increment and skip if 0, and meaning is like this, increment and skip if it is 0, okay. And in this case what happens, you see very that is a lengthy process. One part is data transfer to memory, again memory data will be increased because MAR plus 1 memory data is increasing. Next, and another part is that data store into the memory, and if condition is there, if this particular DR data is 0, because this is DR data, if DR data is 0, then PC is increasing. This is the basic concept. Now I will just define in this way. So D6 T4 data, you see, first of all, that is memory data stored in a data register. Memory data, this memory data stored in a data register. You see, memory data stored in a data register DR. Here memory data, address register in from memory store in a transfer to data register. Here D6T5 at that time, then what happens? You see, it is increasing. This memory data will be increased. DR is equal to DR plus 1 because this data is a DR. So now we see DR is DR plus 1. Okay. Next is some condition. DR is 0. Okay. DR, that is some condition. DR data, if that, then what happens? We see D6 T6. Then memory data, memory address register is DR data. DR transfer to memory. Okay. If the condition is DR, if condition is DR, because you see very simple way here mentioned DR means now DR plus 1. Here is DR plus 1 is DR. So DR plus 1 is DR is 0, PC is increasing. So this MR DR transfer to memory, if DR is equal to 0, okay, then PC is increasing, PC plus 1, okay, then PC is equal to PC plus 1, then SC is equal to 0, okay. So in this way we can define different ways. What are the that is operation is given, symbolic is description is given, then we have to define accordingly, okay. There is no confusion because the different concepts are there, we have to define accordingly. So this is the basic concept regarding on, that is memory reference instruction, how memory reference instruction is defined in different ways. I already shown to you. So this is the basic concept regarding on memory reference instruction, how it is defined. I already told this memory reference instruction is very important to define, and whenever define through different category of instruction, how different instruction is designed as per this particular symbol, operations, and some symbolic description. Okay, I hope all of you understand this particular topic. Okay, if you like, you also like our videos, and if you want to progress our channel, you can subscribe our channel. Okay, thanks to all.